Okay, here's your guys' Math 3 Fall 15 week mock exam. Um, okay, so for number 1. Okay, so for number 1, we have imaginary or complex numbers. So first what I did was I just multiplied 5i times 7i. So then we get that right there. And just remember that I squared is -1, right? So then basically 28i squared becomes 28 times -1. And of course this, right, just comes from this, and I just rewrote it. Okay, 28 times -1 will give you guys -28, and then from there you guys just distribute -28 to 6 and -28 to -6. And then this will be your guys' answer. So that's how you guys would do number 1. Okay. Number 2. Now, this one, on the other hand, in order to solve for something like this, you guys gotta multiply top and bottom by the conjugate. And the conjugate is basically the denominator, but the I value is the one that becomes the opposite. Only the I value. So since that's 2 minus I, the conjugate would be 2 plus I. So multiply top and bottom by the conjugate. And then we gotta do distributive, right? Of 2 sets of binomials. Okay, so we'll do the top. We got 8 times 2, and then 8 times I. And then we got 5i times 2, and then 5i times I. So we're going to get 8 times 2, which is 16. 8 times I, 8i. 5i times 2, 10i. And 5i times I is 5i squared. Alright? Now for the bottom. 2 times 2, which would give us 4. 2 times I, 2i. Negative I times 2, negative 2i. And negative I times I will give you guys negative I squared. Okay, so now let's focus on, after we multiply that out, let's focus on the i's, okay? Now remember, I squared is -1, right? So basically, I just simplified the 5i squared to be 5i squared, which is 5 times -1, which simplifies to -5. And that's how I got this right there. And then recall, -I squared, that's mainly -1 times -1, which is simply just 1, which is how I got 1 right there. And then of course I just simplified everything else, so I saw that these cancel, so that's why they're gone. And then 8i plus 10i is 18i, which is how I got that 18i. Okay, so just a lot of just multiplying and doing algebra, and then just simplifying that, you guys. You get 11 plus 18i over 5, and then to just split it, you just do 11 over 5 plus 18i over 5. And for that answer, and you guys would have gotten A. So that's how you guys do number 2. Alright, so for number 3, solving for a quadratic formula. So basically, right, you gotta get everything to one side of the equation. So I just made everything go to the left-hand side. So I just added by 10 and added by 6r, and I did that to the left-hand side as well. On the right-hand side, you guys are going to get 0, but on the left-hand side, you're going to get 6r squared plus, make sure you put 6r, right? Standard form, and then plus 10. Then, once you guys put everything on the left, I labeled this as my A value, this one as my B, and this one as my C. And then, good old quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. Substitute all my a's, b's, and c's into the formula. And then, once you guys do that, I'll make it so that it reaches right there so you can see both. So -6 plus or minus, now remember 6 squared is going to be 36, right? And, well, internet connection, you love to see it. There we go. Okay, so 6 squared is 36. Okay, negative 4 times 6 times 10. That's going to be negative 240. Okay, negative 4 times 6 times 10, negative 240. Okay, so moving on to here. 36 minus 240 is going to give you negative 204. And I forgot to mention this before, but remember, 2 times 6 is going to give you guys 12. Alright, so now we're essentially here. Now you guys have to simplify that. You gotta simplify that square root of negative 204. So let's look at the simplification and let me explain it. Okay, so when I simplify that, right? First off, let me just get rid of the negative inside the radical, right? So the negative sign of the radical, that's really I, right? I is equal to radical negative 1. So we can pull that out and put the I on the outside, and then that gets rid of the negative on the inside of the radical. And then we simplify, now we just simplify the radical 204. Well, I know 2 times 102 is 204, which is how I got there. 102, that factors into 2 times 51, and then 51 factors into 17 times 3. So that's the factor tree. Now, I noticed that I could find a pair there. And the pairs, you guys, come out on the outside. So that pair of 2 comes on the outside, and unfortunately the leftovers still stay on the inside. So 17 times 3 was radical 51. So that's how I simplified it to 2i radical 51. Now back to the problem. Remember this, we simplified it to be this. Now, we are here. Now, notice that negative 6, 2, and 12 can all be divisible by 2, which is why I divided top and bottom by 2. So, negative 6 divided by 2, negative 3, 2i divided by 2, I, 12 divided by 2, 6. And the radical does not get touched, so then basically that is your guys' answer. R is equal to negative 3 plus or minus I rad 51 all over 6. And that looks to be choice A. Okay, number 4. Now, number 4, this looks to be by grouping, right? Because there's 4 terms, and usually if there's 4 terms, it's always a good idea to do by grouping first to see if it works. So, first off, 4, I notice everything can be divisible by 8. So, 16 divided by 8 is 2. Negative 24 divided by 8 is negative 3. Negative 64 divided by 8, negative 8. And 96 divided by 8 is 12. Now, after I pull out that negative, or pull out the 8, I notice that I could group these. I could group those 2, and I could group those 2. Okay, so in the first set of parentheses, I see from here that we can factor out an x squared, which is why I factor out an x squared there. And then from this set of parentheses, I'm going to factor out a negative 4, which lets me get there. And then notice, this is perfect because I notice that these are the same. So then basically, to get this into, or factoring by grouping, x squared minus 4 is going to come out from what we factored out, and then 2x minus 3 is going to be right here, because we can essentially factor 2x minus 3 out from both of these. Okay? So, we got that. Now notice that this can also be factored because it's a difference of squares. So square root of x squared, x, square root of 4, 2. X plus 2, x minus 2. And everything else is still the same. So that's my factor. And then when I look at number 4, I notice that D is the only choice for that. Okay? Alright, so there is that one. Now we're going to move on to number 5. Okay, number 5. This is function composition. So recall g of h of x really looks like that. So when I look at that, I'm like, okay, we already know h of x, which is that. So I'm going to substitute this in for right there. So when I substitute h of x into here, I'm going to get g of x squared plus 2x. See, x squared plus 2x is really our h of x, right? So I just substitute that function into there. Now, after this step, notice that, okay, now we're going to substitute that x squared plus 2x everywhere we see an x in the g of x function, right? So, since x squared plus 2x is now our x, the only place I see another x is right there, which means in that equation, our x is now going to be x squared plus 2x. Okay, then we just distribute this to both of the 2 in the inside, and then we're going to get 3x squared plus 6x plus 1. And that's going to be part A. So the key thing is to remember that is g of h of x, and substitute the h of x into the equation. And then from here, use g of x and substitute x squared plus 2x everywhere you see an x. Alright, moving on. Number 6. Alright, so we first start with here. G of f of 3, right? So first, let's substitute 3 into our function. So substitute 3 into there. We're going to get f of 3 equals 3 to the third minus 1, which simplifies to 26, right? Now, we found 26 for f of 3, so we're going to substitute it there, which is there. So now, g of 26, now just substitute 26 into our g function, right? So 4 times 26 plus 2. 4 times 26 is 104 plus 2. 104 plus 2, 106, which is B. Alright, good stuff. Good stuff. Alright, number 7. Okay, so a few things for number 7. So first is a quadratic, so you know it's going to be a happy face or a sad face. So since it's positive 2, right? You know that's going to be a happy face. So you know your graph is going to be concave up. Now, do you guys see how it says a is greater than 1? So since 2 is greater than 1, you know it's going to be a stretch. So you know your function is going to stretch vertically. And then to find your vertex, you do your negative b over 2a. So our b value is 8, so it's going to be negative 8, and then our a is 2, so 2 times 2. Negative 8 over 4, which is negative 2. So there's our x value of our vertex. Now substitute that into the equation in order to get your y value for your vertex. So I substitute negative 2 into the function, get that down, and you're going to get 2. So let's erase this. So there's my vertex. So let's look at our set of graphs for clarity. So negative 2, comma 2, the only one that gives me that is these two. Now remember, well, they're both happy faces, but which one looks the most stretched vertically? And this one is, right? That one is stretched out more vertically. It's as if you guys have a rubber band and you pull it vertically, and notice that it gets skinnier, right? So C would be our answer. Alright, so for number 8, okay, this one, the one before, that one's in standard form, okay? This one right here, you guys, that's in vertex form. So in vertex form, this one, you guys, that's your x value, but it's the opposite. So it's 2, and then this is your y value. You just take that, so it's negative 3. So in vertex form, you guys can get the vertex, and then this is negative, right? So that means it's going to be concave down, sad face, and then it's 1/2, right? And if 1/2, then that means it's a shrink, which means it kind of gets widened out more, right? So if you guys look at your options, this one is sad face, and this one is sad face. Now, the one that has a vertex of 2 comma negative 3 looks to be like D. So D is going to be our answer, because it's sad face and the vertex is at 2 comma negative 3. Okay, so moving on, we got number 9 now. Alright, so this has to do with your guys' using, or what is this? Oh, finding your roots, finding your guys' roots using the rational root theorem. So first, if you guys recall, you gotta find the factors of P. So that's P, this one's Q. Factors of P is 1 and 2, so it's gonna be plus or minus 1 and 2. And factors of Q, which is 15, factors of 15 is 1 and 15 and 3 and 5. So that's how I got my P over Q. Then recall, to get all of those, what you guys essentially have to do is 1 divided by 1 is 1. 2 divided by 1 is 2. And then you guys keep on going, okay? 1 divided by 3, 1/3. 2 divided by 3, 2/3. And then the next one, 1 divided by 5, 1/5. 2 divided by 5, 2/5. And then for our last combo wombo, 1 divided by 15, 1/15. 2 divided by 15, 2/15. So that's how you guys get your possible rational zeros. And if you guys take a look at all your options have that. So I mean, that's how you guys do it, but if you guys just look at your options and you're just kind of like, okay, they kind of give us that information. Now, to find your number of real zeros, and all of them say that, right? Possible number of real zeros. All you guys have to do is just take the highest degree and then subtract 2 as many times as you can until you reach negative. So, for example, this is the one we have, right? So to find our possible number of zeros, first, your highest degree is 3. Then subtract by 2, 1. Now, if you keep on going, right, 1 minus 2, negative 1, negative 1 minus 2, negative 3, you can't have possible zeros of, you can't have negative 1 possible zeros. It just does not make sense. So just keep on subtracting by 2 until you get to your negative values. That's how you guys find your possible real zeros. So, since our possible real zeros are 3 and 1, you can automatically get rid of this one, right? Because it says 4, which does not make any sense. Okay, now, if you guys look at your possible zeros, usually if you guys didn't have multiple choice, you guys would just have to guess and check and use synthetic division. Now, if you guys look at your options of A, B, and C, and D, well, do you guys see these? Those say 0, right? That's not in this list, right? There is no 0. So then 0 is not even a possible one because it's not even on the list. So then it doesn't make sense that those work, which means D has to be your only answer. Now, if you're curious, if you were to guess and check off of that list on which one will give you guys a remainder of 0, I decided to do synthetic division. So 15, I'll zoom out so you guys can see the function. To do synthetic division, right, you gotta write down all of the coefficients. So do you guys see the coefficients of 15, 13, 12, and 2? 15, 13, 12, and 2. So you write down all your coefficients, and then your you get from your possible list, and then you just substitute it in to there, right? And then you guys have to do multiplication, addition, multiplication, addition, multiplication, and addition, right? So drop the 15. 15 times negative 1/5 is negative 3, and then you add, right? For 10, 10 times negative 1/5, negative 2, add 10, 10 times negative 1/5, negative 2, add, we get 0. So you know negative 1/5 is one of our zeros, which the only possible answer would be D. Okay? And I just showed you right here, you guys, as proof that 0 is not one of our rational zeros, because when you guys do that, then you get a remainder of 14, which automatically means it's not a root. Okay, that's number 9. All right, number 10. Now, this one requires some, well, actually all of these are a review, but start from scratch. So, if your guys' highest degree is positive and it's an even power, that means the end behaviors go up and up. If your highest degree is negative, if it's negative and your highest, if your highest degree is even and has a negative sign, then it goes down, down. Positive odd goes down, up, and negative odd goes up and it goes down. So that's all your end behaviors. Now let's look at the R's. Okay, that one, right? That's our highest degree. It's positive and it has an even power, so we're looking at this, which is why I did up, up. Now, follow along, okay? Since you know it's up, up, as x approaches infinity, which means going to the right, the direction y or f of x is going to infinity. Your y is increasing. So as x increases, then the y is increasing. So as x goes to infinity, the f of x is increasing, going up. Now, as x goes to negative infinity, going towards the left, or decreasing, then your f of x is increasing. It's going up. So that is why A is your answer. You have to look at your end behaviors. Now let's take a look at this one, right? So it's negative and it's an odd. So negative odd means it has this type of end behavior, right? All right. So as x goes to infinity, as x, which is that one, goes to infinity, f of x is decreasing, so it's going down towards negative infinity. So as x goes to infinity, f of x goes to negative infinity. These two are the only two options that have that, right? Now we need to look at the second part. As x goes to negative infinity, so you're looking at your left arrow, looking at the left one, then f of x goes to infinity because it's going up. It's increasing, right? So the only one that is this option, which is why A. Look, this one's negative infinity, negative infinity. As it's going to the left, this arrow is going up, not down. So our only option is A. That one, you guys just have to remember your guys' end behaviors. That should help you guys. Okay, so 10, 11. Now we are on to 12. Okay, so for 12, it says write a polynomial function of least degree with integral coefficient that has the given zeros. So they give you guys negative 3/5 multiplicity of 2, which means there's 2 of them. There's 2 zeros at negative 3/5, which is why I wrote negative 3/5 twice. And there's an x at 3. There's a root at 3. So that's why I wrote x equal to 3. Okay, so to find your guys' equation, right? So pretty much you just set all of these equal to 0. So for these ones, right, multiplied both sides by 5. So I get 5x equals negative 3 for both. And then I just added by 3. So then we get 5x plus 3 and 5x plus 3. And then right here, to make it equal to 0, just subtract 3 from both sides for x minus 3. And then all you guys have to do from there is you just have to multiply all 3 of these binomials together in order to get your polynomial. So I just decided to do left to right. So 5x times 5x is 25x squared, 5x times 3, 15x, 5x times 3, or 3 times 5x, 15x, 3 times 3 is 9. And don't forget the binomial x minus 3, right? Because it still comes from right there. Okay, so I'm still moving along. So collect like terms there, which means we're going to get 25x squared, 30x plus 9 times x minus 3. And then I just multiply my binomial to my trinomial, so x times 25x squared, x times 30x, x times 9, negative 3 times 25x squared, negative 3 times 30x, negative 3 times 9. So Switching gears. Negative 3 times 25x. Sorry, I'm going to brain freeze. Oh, x times 25x squared, negative 25x third. X times 30x, 30x squared. X times 9, 9x. Negative 3 times 25x squared, negative 75x squared. Negative 3 times 30x, negative 90x. Negative 3 times 9, negative 27. So I color coordinated it for you guys so that you guys can see the like terms. So we're just gonna get 25x to the third, 30x squared minus 75x squared is negative 40x squared. 9x minus 90x is negative 81x and negative 27. So that's our function, which would give us b. Now, you guys can always check too if these are correct by using synthetic division for these, right? So what you could do is I would first test out 3, right? I would do 3 for all of them and then see if you could do synthetic division with 3 and see which one will give you a 0. So this is what I did. I know they gave us that 3 is a 0, so 3 goes there, and then I just wrote the coefficients down of so you're just gonna have to do trial and error, right? Trial and error on these. So I decided to pick this one out to test the 3. So when I tested out and did synthetic division, drop the 25. 25 times 3, 75, add it, 30, 30 times 3, 90, 90 plus negative 81, 9, 9 times 3, 27, 27 plus that is 0. So I know my equation is good. Again, you guys would just guess and check for all of these and see which one would 3 work for using synthetic division. My gosh, I cannot speak. Okay. And of course you could do it for negative 3/5 for fractions for more practice. Okay, so for 13, right? Still dealing with higher degrees, powers of 3 or greater. So notice that the leading coefficient is negative and it's an odd power. So I know it's negative odd, so I know the end behavior is going to be up and down. So when I look at our options, I can automatically get rid of that one, right? Because that one doesn't even have the correct end behavior. Okay, number of turns means like how many times you guys see a minimum and like a maximum, right? When you see a minimum max, then you guys see turns. So in order to find a turn, you guys just have to subtract the highest degree by 1. So since the highest degree was 3, right? 3 minus 1 is 2. So that means we're going to have 2 turns. Well, they all have 2 turns, so that doesn't really help us. Possible number of zeros, remember, take the highest degree and just keep on subtracting by 2, right? To give you guys your possible. So since 3 is our highest degree, and then 3 minus 2 would be 1. So our possible zeros are 3 and 1. So I could get rid of this one because do you guys see how it says number of real zeros is 2? Well, we can only have possible zeros of 3 and 1. So it can't be that one. And then you're debating between A and C. So what I did was, well, I can see that this one has a y-intercept, right? And then this one, like, it will, but I can't determine that. So I was just like, all right, well, I'll just find the y-intercept. So substitute 0 for x into the function. You guys are going to get f of 0 equals negative 0 to the third plus 3 times 0 squared minus 1. But all of that goes to 0 except we still have negative 1. So I know my y-intercept 0, negative 1. And the only one that reflects 1 with 0, negative 1 happens to be right there. So that's why I'm going to pick A as my answer. Okay. We're at 14. Okay, so here's rational expressions. Now we got a negative sign, right? So in order to do rational expressions, you have to get these to be the same common denominator. Well, this one's missing n minus 1. This one's missing n plus 3. So for this one, I'm going to multiply top and bottom by n minus 1 because that's what it's missing. For this one, I'm noticing it's missing n plus 3. So I got to multiply top and bottom by n plus 3 for that one. Now, we have, once I multiply, okay, so for n, you got to multiply it to both of those, right? So 4n times n, 4n squared, 4n times negative 1, negative 4n. Now, do you guys see this negative sign? Do not forget this negative sign. The negative sign is with that 7. So negative 7 times n, negative 7n, negative 7 times 3, negative 21. And then, right, since we did that, these are just going to be, they're going to be the same common denominator. So n minus 1 and n plus 3. Then you guys just simplify the top. And basically, all you gotta do is just combine those. So 4n squared minus 11n minus 21. All over n plus 1 and n plus 3. Okay. So there's that one. 15, right? Rational expressions. You have to get the common denominator. So for 3n plus 4, I'm noticing it's missing that one, right? So I'm gonna multiply 3n plus 4 by n plus 1s to top and bottom. N plus 1, I notice it's missing 3n plus 4, which is why I multiply top and bottom by 3n plus 4. Okay, so distribute 2n to both of those for 2n squared plus 2n. Distribute 4 to both of those for 12n plus 16. All over the same common denominator. And 1, 2, 3. Then these two combine, so we're going to get 2n squared plus 14n plus 16, all over the same common denominator. Remember to get the same common denominator when you guys are doing your addition and subtraction of rational expressions, okay? All right, 16 and 17. So this is solving for your guys' rational expressions, okay? Or sorry, solving rational equations. So first thing you guys gotta do is factor the denominator, okay? So that means we gotta factor these out. They're both the same, so I only have to show you two at once. Okay, so when you guys factor, right, 7 and 1 are the factors, and the possible factors of 1 and 6, so that means 7 and 1 would be there, and then you guys have to just guess and check. Is it 1 and 6, 6 and 1, 2 and 3, or 3 and 2? Well, I know it's 6 and 1 because 7 times 1 is 7, 6 times 1 is 6. 6 plus 7 will give you guys your middle term of 13. Now, if you're one of the people that likes to do it with the x method, just do this. Since a, right, since your a value is not 1, it's 7, you gotta do this additional step. So, your a times c, which is 7 times 6 is 42. The middle term's 13. So what two things multiply to 42, but when added gives you guys 13? It's 7 and 6. So since a is not 1, that means you have to write this first term twice. Right there and right there. Now, these two that you found, right? You do 7v, you have to add a variable, and 6v. Then you guys just simplify it, right? And you're going to get v over 1 and 7v plus 6. So v plus 1 and 7v plus 6 are your guys' factors, if you guys want to do it through x method. Okay, so back to the problem. We factored out these two, right? Because they're the same, into 7v plus v plus 1, right? Okay, so now what you're going to do is you're going to be finding the LCD and multiplying the LCD to each one. Now before we get into that, remember, make sure that you set your denominators equal to 0, because it can't be 0, because then it will give you guys a fraction, something over 0, and you can't have that. So just write your excluded values just to make sure. Okay, so what we do in my class is we multiply every single one by the LCD. So then if you guys notice, I multiply every single expression by the LCD. See? Multiplying each one by the LCD. Now what that lets us do is it lets us to cancel, right? So we get to cancel 7v plus 6 and v plus 1 for this one. For this one, we get to cancel 7v plus 6, and this one we get to cancel both as well. Now remember, this negative, do not forget that negative sign, because you guys have a tendency to do so, and it's a careless error. So we're simply going to get 8 minus v plus 1 equals 1. Distribute the negative to both, and we're going to get 8 minus v minus 1 equals 7. Or sorry, 1. So you guys just simplify and go from there, and you should get v is equal to 6. Now remember, check your excluded values, because if what you found is in your excluded values, that means it's called an extraneous solution, which means it can't be one of your answers. Okay, so v equals 6 is your guys' answer, which is D. Now let's take a look at this one. Okay, so for 17, just factor out that denominator, which is b minus 5 times b plus 1. Okay, now for here, LCD is this one, right? And then make sure you set them equal to 0 or not equal to 0 so that you guys know your excluded values. Okay, then from here, we just multiply each part by the LCD. And we get that. Nothing cancels because it doesn't have a denominator. Okay, right here, both of them cancel, and then right here, only b plus 1s cancel. So then we're going to have 3 times b squared minus 4b minus 5. Remember that is simply this, right? Because that's the factors of that. Then we got to distribute the 3. Okay, right here, all that's left over was this, right? Which is why I just rewrote it right there. And then this part, we have to multiply 3b times b minus 5. A binomial times a binomial. So that's how we get that. Now, once you guys simplify that, 3 times b squared, 3b squared, 3 times negative 4b, negative 12b, 3 times negative 5, negative 15. And then after you guys multiply that, notice I just color coordinated it so that you guys could just collect like terms. And on the right hand side, right, it's just multiplying that. So 3b times b was 3b squared, 3b times negative 5, negative 15b, negative 21b, and negative 21 times 5, negative 5 is 105. Okay. Collect the like terms to get this, and then now you guys just set everything equal to 0, right? So I just moved everything to go to the left hand side, and then I eventually get here, and then here I notice I could factor out a 3, and then there the factor of b squared plus 3b minus 5b, the trinomial of that is that factor, right? And then solve for 0, and you guys are going to get negative 9 and 6. Now, make sure you check your excluded, making sure there's none there, right? Looks to be good, so that means our answer is 6 and negative 9. Okay? Alright, so there's those two. Now let's get into this. So, this first one, it's a bunch of transformations, right? Hint, because of this, and that. So, parent function f of x equals 1 over x, right? So usually the parent function's graph lies in the first and the third quadrant, right? Now, take a look. First, notice the vertical asymptote and the horizontal asymptote, right? It's negative 3 and it's negative 1. Negative 3 because you set the denominator equal to 0, right? And the horizontal asymptote is negative 1 because this thing right here has a horizontal asymptote of y is equal to 0, but then it gets pushed down negative 1, which pushing it down 1. So vertical asymptote is negative 3, and horizontal asymptote is y equals negative 1. Now when you guys look at your graphs, you should first see which graph is graphed correctly, because vertical asymptote of negative 3, this one's good, This one is not at x is equal to -3. This one isn't either. And this one isn't either. So just from looking at the vertical asymptote is your answer. Now, they're not all going to be like that, but you guys should just check your vertical and horizontal to see which graph is graphed correctly. Okay, horizontal asymptote. B is not good for horizontal asymptote either. This one is not either. This one's good for horizontal asymptote, but we already know that one fails because it doesn't allow you guys to graph the vertical asymptote properly. And then for even more reassurance, remember, since it's negative and it reflects across the x-axis, you know it's going to be in quadrants 2 and 4. This is the only one in quadrants 2 and 4. This one's still in 1 and 3. This one's good in 2 and 4, and this one is good for, or this one's not good. So, right, there's many ways you guys can test to make sure if these graphs are proper, right? You know it's A because that's the only one that graphed the vertical asymptote correctly. But, you know, you guys just use your knowledge of, like, if it's negative for the parent. Remember, if we're using parent functions, right? Yeah. Okay. Looking on at 19. Okay, so what I did was I factored this stuff out first. So on the top, I factored out a negative x. And then here, I just factor that trinomial to be that. Now when you factor that out, notice how x plus 2 cancels, right? And then we're going to get this for our final equation. Now for our whole, right, what you cancel is what you set equal to 0. So since we canceled x plus 2, we got to set that equal to 0 to find our whole of x equals -2. Vertical asymptote, you set the denominator equal to 0. So that's how we get x minus 4 equals 0, which is x is equal to 4. Horizontal asymptote, you look at your original and you look at the degrees, right? That one's highest degree is 2, that one's highest degree is 2. So the degrees in the numerator and denominator are the same. So that means you just look at your coefficients. Coefficient of -1 over 1, which is simply going to be y is equal to -1 for your horizontal asymptote. X-intercept, set the x or numerator equal to 0, and that's just going to be x equals 0 for 0, 0. And y-intercept, you just substitute 0 in for there, which will just be 0, so 0, 0. And then test point, right? X equals 4 is your guys' vertical asymptote, so you do a test point to the left of the vertical asymptote and one to the right. X equals 0 is a value to the left, so basically you have to test substitute 0 in for your function, which is right here. So you know it's going to be at 0, 0. And then for a value to the right of the vertical asymptote, 5. So substitute 5 into there, so then we get -5 over 5 minus 4 for -5 over 1, which is -5. So that means 0, 0, you know it's going to, well, and then you guys from there, since you have your test points, now you guys should just use what knowledge you know to see what works out. So I know my vertical asymptote's at 4 first, right? So can't be that one because that's vertical asymptote's at 2. This one's good because that vertical asymptote's at 4. This one's no good because that one's at 0. And this one's no good because there's 2 vertical asymptotes. We only have 1. So B looks to be your guys' answer. Again, right? You guys should just look at all the information that you have, right? Solve for what you know and then see what lines up, right? And then, right, if two choices have the same vertical asymptote, then just keep on looking at like your horizontal x-intercepts and y-intercepts and making sure all of your information matches up, right? And just to add on, y is equal to -1, right? That's good. There was a whole at -2, which was right there. Vertical asymptote's good, and x-intercepts and y-intercepts at 0, 0, right? all the information you guys add just adds more emphasis on your correct graph. All right, looking at the last one, number 20, right? So looking at our equation, from the bottom, I factor out a 4x to get that. And then this trinomial, I can factor out to x plus 3 and x plus 2. Notice that x plus 3's can cancel. So then I just get that. Whole, set what you cancel equal to 0. So since I canceled these, that's where my whole is. So x plus 3 equals 0 for x equals negative 3. Vertical asymptote, set the denominator equal to 0. Did so. For x equals 0 or x plus 2 equals 0, x equals 0, x equals negative 2. So I got 2 vertical asymptotes. Horizontal asymptote, you guys just look at your degrees, right? Degree of 1, degree of 3. The bottom has a bigger degree, which means you have a horizontal asymptote of y is equal to 0. X-intercept can't set the numerator equal to 0, but 0 can't be 1, so that means it's none. For y-intercept, substitute 0 into your guys' equation, but if you guys notice, you're going to get 1 over 0, so that's also going to be none. Now I just did test points to just have you guys just check it just to make sure. Now let's see what our information tells us. Well, vertical asymptotes, there's going to be 2 vertical asymptotes. So can't do that one, that only has 1 vertical asymptote. This one has no vertical asymptote, and this one only has 1. So that means your only option is it has to be A. Again, you guys should be able to know how to do all this because it's good to emphasize like what you know and everything. Like for example, I know this graph is still correct because there's a hole at negative 3, horizontal asymptotes at there, and yeah. Just further emphasize that choice A is my correct answer. So, hopefully that helps you guys. Study up, okay? We want you guys to be as successful as possible, so just try your best, okay? Hopefully this helps, and peace out.